Okay, Assalamualaikum and welcome back to Dynamics ECS 429. We are at week 4 and today is 1st of November 2021 and it's 11:24 a.m. and it is shining brightly outside. Itu macam weather forecast kah? Forecaster pula lah kan? Okay, am I presenting my screen, guys? Can you see my screen?
Yes.
Nampak? Okay, all right. Now, okay, so curvy, macam mana nak keluar button tu? Okay, curvilinear motion. Okay, so we're still in topic curvilinear motion. This is topic 1. Okay, all right. So for curvilinear motion, last week we have learned a lot on the rectangular coordinate system. Okay, the rectangular coordinate system, and then you also learn about the non-rectangular coordinate system. Okay, so those are the things that you have learned. And for the non-rectangular coordinate system, last week we learned about solving problems related to normal and tangential. Okay, so for today's class we're going to do solve a problem related to radial and transverse. Okay, all right, so basically when you get a topic related to curvilinear motion, you have to identify, is this a rectangular coordinate system problem or is this a non-rectangular? And then if it's a non-rectangular, are you going to solve it using normal and tangential or radial and transverse? So that's it. For curvilinear motion, you have to decide. Okay, so if you notice, topic 1 is a lot. It's very lengthy. It's a lot of input have been taught. But when you go to topic chapter 2, 3, 4, you will see it will start to reduce. The topic is not as lengthy as this one, so you'll be okay. But however, as long as you know this question is a curve linear question, it is moving in a curved path, and which method you want to solve it, you decide, inshallah you can solve it. It's going to be very easy for you. Okay, it's not going to be difficult. Okay, so can we proceed? So now we're going to learn about radial and transverse. Last week we learned about normal and tangential, right? You're okay, guys? You're okay, right?
Okay.
Okay, all right. Now we're going to learn about the cylindrical motion, the curvilinear motion, which is the cylindrical components. Okay, which is today's class is on radial, which we usually use the symbol R, and transverse. Okay, theta. Okay, now sometimes the motion of a particle is constrained on a path. So when you have a motion that is constrained on a path, and it removes moving in a curved line, then we can use radial and transverse. So the key point here on how you want to identify is understanding what it means. So what it means is when motion, okay, of a particle, okay, is constrained on a path. Okay, so when a particle the motion is constrained on a path, then we can use radial and transverse. What it means is the motion is restricted to the plane. Okay, but when it's restricted to a plane, but we can use polar coordinates to solve the problem. So another way is it's restricted to a plane. Okay, all right. Okay, so for a good example is if we draw the diagram. Okay, let's say we have a origin point here like that, and then we have a particle. Let's say this is our particle that we are investigating. Okay, and then this origin has a horizontal axis, okay, like that. Okay, and this particle is moving along a curved path like that. Can you see? Something like that. Okay, or like that. They're moving along a curved path. Okay, so since if this particle is moving along a curved path, however, is constrained along this path, then we can use radial and transverse. Okay, all right. So this is the example. Okay, all right. So let's say this is our theta. Okay, okay, and then okay, so we need to identify the transverse and the radial. Okay, let me explain to you first what it is. Okay, all right. So we can basically what we can do is we can specify the coordinates of this particle using the radial coordinate. Radial coordinate is r, which extend outwards from the origin O. So this one is, we can say this as r. Okay, this is the radial coordinates. Yeah? And the transverse coordinate theta, which is counterclockwise angle, which is fixed at the reference line, a fixed reference line R axis. Okay, so this is theta. Okay, and it must be perpendicular. Okay, so here this is your R and this is your theta. Okay, all right. So usually R, the vector, we define the vector as UR, and we define the vector as U theta. Okay. Kenapa tulisan macam tu? Sekejap. Oh, this is error. Arrow. Let me write it. Okay, this is UR. This is U theta. Okay, all right. Don't worry, guys. Just listen first and try to understand first. And then we're going to use an example and then you will understand better. Okay. So usually the angle, okay, this angle, does somebody want to join our class? I heard this one. Alif Azhar. Okay. Okay, guys, can I continue? Boleh? You okay? Are you okay? All right, just listen first, eh? So, so the angle here, usually the angle, usually we measure in degrees or radian. If you have a degree and you want to change it to radian, what do you need to do? Multiply by what? 1 radian equals to how many degrees? 180 divided by pi. Are you familiar with this formula?
Yes.
Yeah.
Okay, good. Okay. So the positive coordinates of the r and the theta are defined by this vector, which is unit vector ur dengan u theta. Okay, you understand? The positive coordinates of the r and the theta is defined by the vector coordinates, this one, ur and u theta. Okay, next. So what is ur? Okay, let me write in a different color. So you guys are copying, right? Okay, so what is ur? Okay, so ur is the direction. Okay, ur is in the direction. Okay, ur is in the direction of increasing r. Okay, when theta is held fixed. Okay, so UR is in the direction of increasing R. So R ni boleh increase, but theta is held fixed. Okay, this theta is fixed and then R can increase. Okay, and then U theta pula, okay, is the direction of increasing theta when R is held fixed. Dia terbalik lah. So when R pula kita fix, theta ni boleh increase. So theta ni, length ni, theta ni dia boleh increase. Okay, boleh naik. Tapi dia punya R tu the same. Okay, alright. Understand? Okay. So that is those two definition what it means. Okay, alright. And now some important formulas that you need to remember. Okay. Right. So this is for the picture for position. Okay. So if it's for velocity, it would be the same. Oops. Okay. Let me. Yeah. Sebelah dia sikit. All right. So just to tell you for the velocity diagram, it will be the same. Okay. Okay, let's say this is our particle again and it's rotating. Okay, so again, this will be our V. Okay, this will be our VR. This will be our V theta and our V will be this one. So if you want to find the magnitude of V, it means you need to, what do you need to do? Guys, if you need to find the magnitude of V, what do you need to do? Guys? Yes, square root of V, yes. VR squared plus V? Yes. Good. Okay, good. And do you think it will be the same? So this is for velocity. And do you think this will be the same for acceleration? It will be the same. So just draw so that you understand. Okay. Okay, maybe my diagram is not that nice. Alah, tak cantik lah. I hope you're drawing a nicer diagram than me. Kan? Huh? Are you copying, guys? You're copying, right?
Yes.
Yes.
Okay. All right. I hope you appreciate these notes. Okay. So this will be AR. This will be A theta. And what do you think the acceleration be? Acceleration will be here, A. So if you need to find acceleration, what would it be? Square root of
AR square
plus?
A theta square.
Yes, good. Okay, so you understand all these things. Okay, good. And now we're going to come up with the important formulas. Okay, now what are the important formulas? Okay, now let's write the important formulas up here. Okay, so you have established that you have established these important formulas. What is velocity? So it means if we need to find velocity, it will be VR UR plus V theta U theta. And when you want to find the magnitude, it will be the square root. This is just showing the vector. Okay, but before that, what is VR? Okay, VR is the derivative of the R dot. Okay, and what is V theta? V theta is R theta dot. Okay, so these are new formulas that you need to take note. Okay, maybe we will draw a box so that you remember. Okay, these are important. Okay, these are important formulas. Okay, all right. So it means if you need to find the velocity, if you need to find the velocity, it will be equals to what? What is VR? VR is R dot UR, and what is V theta?
R
Is R
theta dot
dot
U
U
theta.
theta. Okay, so what it means is if you need to find the magnitude of velocity, you need to find the square root of R dot what? Squared plus R theta dot squared. Understand?
Yes.
Okay, so this is the important formula that you need to remember. Okay. 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 This is the important understanding part. Okay. Okay. Now for acceleration. Okay. And then next is for acceleration. Okay, for acceleration. Okay, it's okay, guys. Relax. Let's come up with all these important formulas first. And then for acceleration is AR. Oh, sorry. I think you guessed it already. AR what? ARUR plus A theta U theta. Okay. Now, what is the formula for AR? Okay, now the formula for AR is R double dot, okay, minus R theta dot squared. Okay, and what is the formula for R A theta? So A theta equals to R theta double dot plus 2R theta 2R dot theta dot. Okay. So these are the important formulas. Okay. So this is one important formula here. And these are the two other important formulas. Okay. So let's say you need to find the acceleration. I think you can guess how you need to do it. So acceleration will be what? Acceleration will be the square root of what? Will be the square root of what is our AR? Will
R
be
double
R,
dot
yes, R double dot
minus R
minus R dot, yes, good, theta dot square, jangan lupa, and then square plus R theta double dot plus 2R dot theta dot squared. Okay, all right.
doktor, saya nak tanya.
Hmm?
Yang dekat AR punya formula tu kan,
Yang mana? Ini. Ya.
punya R yang R double dot minus R theta dot square. Tapi dekat yang acceleration square root tu,
Ah.
R dia ada.
Oh, ya, ya, tak ada. Betul, betul. Nasib baik you perasan. Banyak sangat dot-dot ni sampai kita tak ingat. Nasib baiklah open book Okay, dah betul. Okay, dah
Okay,
buang
thank you,
dah.
doktor.
Okay, thank you Alright, okay. Done. Okay. Okay, for this topic, sebenarnya what is important is that you are able to identify this topic kita kena solve using radial and transverse. And then after kita dah decide kita nak use radial and transverse, usually the question is the same. Calculate acceleration, calculate velocity, calculate position, ataupun you nak minta calculate angle. Tak kisahlah apa soalan dia, tapi you know these are the formulas involved and we need to solve it. Okay, alright, good. So that one we done. Okay, so maybe now we can start to do one question together. Okay, have you copied that question just now? Mana that question? Okay. Dah copy dah this question. Dah kan? Let me cut this question. Boleh cut ke? Apa dia jadi sini ya nak cut? Abaikanlah. Apa yang terjadi? What did I do? Nak try cut ni bawa ke sana tak tak tahu lah. Nak copy. Memang. Guys. Okay. Boleh? Sekejap. Padam sekejap Tak lama Itulah kalau kita dekat face to face class, dah lama I suruh you all padam. Dalam kelas kan. Kita suruh ketua kelas padam. Weh. Sekejap padam sekejap ni yang kelas tadi. Sekejap Okay, just you all okay? Are you guys okay?
Okay.
Okay Dah start banyak kerja ke? Okay, sikit. Oh. Okay, dah. Dah terpadam pula dia punya apa? Ni. Alamak, kejap Okay, kita betulkan sikit lagi. At a constant, apa kat sini? Constant at a rotates. Mana cylinder ke? At the constant rate of 60 degrees per second and L is decreasing decreasing at a constant rate of 150 millimeter per second. Calculate the magnitude of the velocity and acceleration of B. Okay, now you need to draw the diagram. Okay, I will draw the diagram for you. Okay, so ada horizontal axis here. Okay, all right. Okay, and there's this piston. Okay, and then there's this particle B. B ni lah particle B ni. Okay, and ini dia punya length. Panjang ni ialah 375 mm. And then this length, back. This length is L. Okay, all right. So, as the hydraulic cylinder, so ni adalah satu hydraulic cylinder, dia rotate around O. So ni point O ni gambar ni point O. And the exposed L of the piston rod P is controlled by the action of oil pressure in the cylinder. So if the cylinder rotates at a constant rate of theta equals to 60 degrees per second and L is decreasing at a constant rate of 150 meters per second, calculate the magnitude of velocity and acceleration of B when L equals to 125 meter. Okay, so when you read this question, if you notice, B is what? Is fixed, betul tak? At a point. and transverse. What was the rule? The particle is constrained along this path, tapi dia rotate macam mana? Macam ni, betul tak? Dia rotate cylindrically. In circular motion, betul tak? Boleh tak guys? Particle ni is constrained along path piston ni, nampak? Tapi dia still moving in a curved line. So, okay, let me just show you myself. Okay. Now, okay. Can you see me? Nampak? Let's say this is your, can you see me very clear? Boleh? Can you see me? Hello, 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 hello. Ke dah tidur dah ni, dah tidur ya? Okay, so let's say this is your hydraulic cylinder. Okay, dia can rotate about point O. Point O hujung ni, so dia can rotate. Nampak? Dia can rotate. Tapi partikel B ni dia boleh naik turun atas. Partikel ni, let's say partikel B tu point dia kat sini. So dia boleh naik turun. So sebenarnya dia punya point yang pertama ni apa yang saya cakap tadi. Dia partikel B ni dia constrain dekat path ni. Tapi walaupun dia constrain dekat path ni, dia boleh rotate atas naik bawah. Faham tak? Ada contoh lain? Sekejap Mana pergi pistol anak saya sekejap Okay. Alright. So, bang. Okay. Oh, tak dengar suara saya bang. Okay. Hello. Nampak saya tak? Clear tak?
Nampak.
Okay. Alright. Okay. Anggaplah ini satu, anggaplah ini you punya partikel B ni. Okay. Partikel B dia constrain dekat axis ni. Say ni straight and boleh naikkan dia. Faham tak? Turun bawah, naik turun bawah. Tapi constrain along this path. So ini satu contoh lah untuk kita that we can relate to radial and transverse lah. Boleh tak? Nak kena tembak dengan saya? Fariha? Nak kena tembak? Mana gun bullet pun tak ada ni. Okay. Alright. Tapi faham tak apa yang masukkan? Macam mana contoh radial and transverse? Ke you all ada contoh lain, example lain yang you all boleh relate dengan radial and transverse yang you all boleh kait rapat? Cuba bagi contoh. Cuba fikir. Di sekeliling you. Apa dia, Fifi?
Maksudnya partikel itu
Fifi tak
boleh
dengar lah
bergerak.
suara you. Apa dia, Fifi? Fifi cakap apa?
Lebih tu dia boleh bergerak dalam tiup tu maksudnya. Dia boleh bergerak.
Yang partikel tu. B. Saya screen saya balik. Partikel P tu, ni partikel B, anggaplah yang warna orange ni.
Madam.
Putus-putus.
Sangkut-sangkut.
Boleh tak? Boleh lah, Fifi. Fifi, are you there? Okay, dah ni. Sekarang? Sekarang dah okay? Dah okay,
okey.
cakaplah kok. Okay.
Okey,
Ke lag
dah
lagi?
okey.
Dah okay belum?
Dah
Okey,
okey
dah
kita.
okey.
Sekarang okey.
Okey sikit.
Ah?
Dah okey.
Sekarang baru
Okay,
okey.
dah okay. Alright, saya teruskan Okay. Alright. Okay. So pertama kita kena yang pertama, kalau tak okay terus cakap tau. Saya tak tahu what is happening, okay, dengan you. Okay. So yang pertama, yang first, we know that the particle, okay, we know that the particle is fixed, okay, at a point and moving on a rotating arm. Anggaplah ini rotating arm tu. Okay. Okay. Yang kedua, kita set up the coordinate system. Okay. So macam mana kita nak set up? Kita tahu kita ada radial R and then kita ada transverse theta. Okay. So kita set up the coordinate system. And we know kita ada radial and transverse. Okay. So kita set up the coordinate system, radial and transverse. Okay, what else? And then we know the direction of the R is the extension and contraction. So kita tahu R, the direction of R ni ada apa? Boleh extend dan boleh contraction juga. Okay, dia boleh extend, dia boleh contraction. Okay, and then we need to come up with the variables. All the variables that we have and the unknowns that we need to find. Okay, so let's come up with the variables that we have and the unknowns that we need to find. Boleh? Boleh class? Can you hear me? Boleh, okay. Alright, let's come up with the variables. Let's read down the question again so that we understand what are the variables, everything. Okay. Okay. Alright. Okay, so dekat sini, what are the variables dia bagi kat sini? Okay, dia kata kat sini, if the cylinder rotates at a constant rate theta. So kita ada theta. Apa value theta kita? Theta kita adalah?
60 degree.
60 degree.
Okay, tapi what do you think theta ni? Theta ni adalah theta ke theta dot?
Theta dot.
Ni adalah theta dot. Sebab ada seconds. So, theta dot adalah 60 degrees per second. Dan ni adalah at constant rate. Betul tak dia kata? Constant rate. So, kalau ini adalah kita punya theta dot, apa theta double dot kita? What do you think kita punya theta double dot is?
Zero.
Kenapa? Kenapa zero?
Sebab differentiate 60.
Sebab theta dot adalah 60 degrees per second. Betul. Lepas tu dia adalah constant. Betul tak? Oh, kenapa I padam buat kata constant ni? Sekejap. Plus dia kata dia adalah constant rate. Bila velocity adalah constant, apa jadi dekat theta double dot?
Zero. Faham?
Dia jadi zero. So what is theta? Theta is the angle, 60 degrees. Okay, so those are the things. So this is the angle. And what is theta 60 degrees per second? Ini adalah derivative of angle. Which is also known as Another term kita guna ialah angular velocity. Okay. And this is derivative, bukan derivative, apa orang panggil? Second derivative. Second derivative of angle. So bila second derivative of angle ni adalah angular
acceleration.
Yes. Okay. Alright. Okay. So sama jugalah kalau kita ada R, and then kita ada apa? R dot, and then kita ada R double dot. Okay, good. Okay, now what is the length? The length of our piston. The length. The length. What is the length diberi dalam question ni? The length is decreasing at a constant rate of 150 millimeter per second. Okay, so dia bagi tahu the length is increasing at a constant rate of increasing ke decreasing?
Decreasing.
Huh? Decreasing. So bila the length is decreasing at a constant rate, what will be, will we have a negative? Ada negative lah. 150 millimeter per second. And bila dia kata decreasing at the rate of negative 150 millimeter per second, ini adalah kita punya L dot. So ni pun dia cakap ada constant apa? Rate. So when the constant rate, when your length is decreasing at a constant rate, you punya L double dot berapa?
Zero.
Zero.
Okay, but how about L? Now, L kat sini, if you read the question, cuba read the question. Dia kata calculate the magnitude of velocity and acceleration of B when L is 125. So dia nak tahu bila L is 125. So our L is at 125. Okay. So at L equals to 125, what is V, the magnitude of the velocity, and what is A? So these are the things that we need to find lah. Okay, now, so going back to the formula, do you remember what is the formula? Write down back the formula. Okay. Padam ni sikit. Dah. Okay. Let's write down back the formula. Okay. Okay. Always write down back the formula. Okay. What is the formula for velocity? Do you remember? Okay. The formula for velocity is what? R dot UR plus
R theta dot U
yes,
theta.
R theta dot U theta. So what is our R dot? Tak ada lagi kan? What is our R? Okay, cuba tengok gambar ni. What is our R? Okay, what is the length of our R? This is the length of our R. Sini sampai sini. This is R. So what is our R? Our R is from point O tau. Cara you nak measure R is from point O. From point O So R is 375 plus apa? L. Okay. So what is R? What is your L? Dalam soalan ni L kita adalah berapa?
125.
Yeah. So what is your R?
500.
100.
Guys, you jangan mistaken R dengan L R must be measured from point O kat sini. Angle pun must be measured from theta, from axis, horizontal axis tu. Okay. So kalau R adalah apa 500. Okay. And then okay, so your R dot is the rate. Okay, rate tu constant rate kan? So sama je lah. Constant rate dia 500, 500 pula lah. 150. So R double dot is 0. Okay, alright. Value R je berbeza. Tapi R dengan L Maksudnya sama at the same constant rate, yeah. Okay, so back here. So what is our R dot? So our R dot here is negative 150. Okay. UR. What is our R? Our R is 500. What is our theta dot? Theta dot kita berapa? What is our
60.
theta dot? Okay. Our theta dot is 60 degrees per second. You must change it to radian. So what do? 60 multiplied by pi divided by 180. Because the answer must be in radian. So U theta. So what is 150? Negative 150. UR. So you need to find the velocity. Senang je lah. Okay, let me just simplify this first. 500 times 60 times pi divided by 180 berapa? Dapat sama tak? 524. Sama tak? So if you want to find the velocity, senang je. Negative 150 squared plus 524 squared. So what is the final answer for the velocity? Betul tak? Do you get the same, Fifi? Do you get the same? Do you get the same answer with me, or are you still calculating?
145.
Sama lah. Okay. Cuba buat
Sama.
untuk acceleration pula. Dah? Are you doing for acceleration? Okay. Next is acceleration. What is the formula? Acceleration is R double dot minus R theta dot squared, and then UR plus R theta double dot plus 2R dot theta dot U theta. Okay, is that correct, the formula? Can you please check for me? So what is R double dot? Ni adalah 0 kan? Okay, that one is 0. Okay, and this one is also 0. So this one is 0 minus R, which is 500. Theta dot needs to change to unit apa? Radian. And then R 500 times 0. So ni dah kosong sebenarnya. Plus 2. What is our R? Our R is R dot. Our R dot berapa? The rate. Change of rate tu. Constant rate tu. Velocity tu. Is negative 150. And what is our theta dot? Theta dot again 60 times pi divided by 180. This is U theta. So this one is berapa jawapan ni? Pakai calculator, tolong calculate. What do you get? Sama tak? 500 times 60 times pi. No. 60 times pi. Tu kena square dulu. Square. Divided by 180. Then baru times 500. Apa I buat ni? What do you get, guys? 60 times pi divided by 1. $574. Betul tak? Dapat berapa tu? 574. Betul ke? Hello? Dapat berapa? Saya tulis kat sini lain. Saya calculate kat sini lain. Blur pula saya sekejap. Dapat berapa?
Sekejap. Yang dah tengah kira.
574. 60 times pi divided by 180 and then squared.
$548.
548. Betul? Betul tak? Sama tak?
Sama.
Okay, so this is the answer. Okay, guys? Okay. Dah?
Doktor, jawapan sama.
Jawapan sama? Okay, alright, good. Okay. Okay, so basically for radial and transverse, the question is, dia punya key point is, the key pointing is here, which I wrote here. Particle is fixed at a point and moving on a rotating arm. So maksudnya dia fixed at a point and they're moving on a rotating arm. Okay, so that is when you see that example, you know that this is a good example. This example represent radial and transverse. Okay. Okay, again, I'm going to tell you, you don't have to worry, because when you start doing other examples related to this, you will find it easy and very straightforward. There's one final exam questions that is on this topic I would like to give you. To me, if you try that example, is sufficient, okay, for you to practice, a good practice. So do anybody have any other questions? And then after that, you need to set up the coordinates and then look at what the variables is given, and then you find what they ask you to find. That's all. The balik-balik is all like this. Okay, pusing-pusing kat sini saja. Mungkin this time tiba-tiba dia unknown dia theta ke, dia tiba-tiba dia bagi velocity ke pun boleh juga. Okay, alright. However, this is how you solve for this question lah. And the concept and formula dia banyak sikit lah. Tapi because you have open book, you should be fine. You just follow the same what is the formula you have given to you, you just write lah. But what is crucial is for you be able to identify what is theta dot, what is r dot, what is r, what is l. All those things that is crucial from you to understanding the question to come up with the variables given. Okay, all right, any questions that you would like to ask? Okay, yes, are you okay, guys?
Okay, doktor.
Okay, all right. Anything else? Okay, group pagi tadi, dia dah discuss dengan saya question on the conveyor belt. Okay, you remember the question on the conveyor belt? The belt is convey from point A from point B. Did you manage to get that answer? You can ask from your friends from the earlier class on how to solve it if you don't have. Okay, or whatever lah. They they have the solution. We discuss the solution together during class. So guys, are you okay? Very quiet. You want to see my view outside? Let me show you. Sebab tu kok senyap. Okay. Nampak tak? Cantik tak?
Cantik.
Kat mana tu?
Kuantan. Ada
Oh,
sesiapa
cute ni.
sini duduk Kuantan tak? Nak belajar dengan saya kat sini. Okay. Ya, saya dekat Kuantan sekarang, tapi kita di mana-mana saja kita masih boleh teruskan kita punya online class kan. Okay. Right. So is there any question? Pagi tadi punya kelas apa? Oh, pagi tadi punya kelas adalah kelas pagi tadi kelas apa pagi tadi? Ni kelas C3 kan? Okay, pagi tadi saya kelas apa? Pagi tadi kelas C2. Ada kawan kat C2?
Tak ada.
Tak ada lah. Kenapa tak ada?
Saya tu.
You ada?
Ada.
Cuba minta kat dia, nanti share lah dekat group.
Okay, nanti.
Okay. So, anything you would like to ask? We can stop our class today. Okay, so kita habis dah topik chapter 1. So kita akan continue next class untuk topik chapter 2. You akan nampak topik chapter 2 lebih menarik, lebih senang, lebih mudah sebab you dah counter yang kesusahan ni masa topik chapter 1 ni. So tapi you fahamlah apa yang melibatkan sebab topik chapter 1 dia tak ada forces involved. Dia basically on the geometric aspect aja. Position, velocity, acceleration and then time lah. So kalau you perasan the questions is the same. Calculate the velocity, calculate the time, calculate the acceleration, calculate velocity, time, acceleration, position. Basically that is the question, and you'll be surprised when you go to topic chapter 2 sama juga, calculate the velocity, calculate the acceleration, calculate the time. But the difference is for chapter topic 2 kita dah go to kinetics. So bila kita go to kinetics ada force F, something is pushing it. Okay, something is causing the motion to move, a force. Okay, there is a force. Okay, for a force involved. That one is topic 2. Topic 1 ni tak ada force langsung. No forces involved. Okay, so when we go to topic 2, you akan perasan there's a little bit difference lah. Tapi maybe much more easier for you lah. Okay, but if you are able to go through this very well with me, you will find the next topic will be easier and maybe a little bit faster. So memang topic 1 kadang-kadang kita drag ke week 4. Okay, supposingly we go to topic 2 now. Kita ada 1 hour lagi, tapi I don't want. I want to save it for next week lah. And then kita punya class this Thursday tak ada cuti kan? Betul tak? Cuti Deepavali. So maybe what you do is you need to find a time slot for me to replace a 1 hour class. Anytime lah. I will give you my class timetable and then you pilih lah when you want to replace the class. Okay, when you want to replace the class, you tell me lah. Then we can discuss lah when it's suitable for us to replace lah, because we're gonna go to topic 2 lah. Kita need to replace just 1 hour slot saja. Anytime kalau you rasa malam boleh, you discuss lah. Nanti ketua kelas come up with the time lah. Okay. Alright. Anything you would like to ask? Are you okay? Okay. You like my view? Pagi tadi air pasang sampai dekat sangat dengan bangunan ni. Lepas tu sekarang dah surut dah. Dah nampak dah semua sampah sarap semua dah ada dah. Itulah. Ada apa-apa? Anything? Tak ada? Semua pun macam manalah saya nak ingat muka-muka you all kan semua tutup skrin. Kan sebab bila kita mengajar kan kita pandang apa whiteboard tu kan kita tak nampak muka-muka you all kan. Kalau nampak muka saya je lah. Tak apalah. Tak nak friend lah macam ni. Duk record pula semua ni kan. Tak apa. I stop recording dulu. Okay. So anything